Today's lesson is about graphs of functions. First, we'll be looking at solutions, how to find a solution with a given value for x. First, I'm going to find f of 2, which means I plug in a 2 for x and solve it. 10 times 2 is 20, minus 7 is 13. So, my answer is an ordered pair. The x value is the 2 that I plugged in, and the 13 is the y value I solved, that I got when I solved. F of negative 1, same process, different plug-in. 10 times negative 1 minus 7. 10 times negative 1 is negative 10 minus 7 equals negative 17. Again, my answer is an ordered pair, negative 1, negative 17. These are my two solutions that I've solved. Next, we'll be looking at graphs of functions and how we plot them. Plotting points should be simple. We've just completed this. We know how to plot points. Finding x and y intercepts, that's what I want to review right now with you. So, x and y intercepts, visually, what does that mean? Well, you should remember from algebra, where the line crosses the x-axis is the x-intercept. Where the line crosses the y-axis, this is what we call the y-intercept. The x-intercept ordered pair has an x value and a 0 for the y. The y-intercept ordered pair has a 0 for x and a y value for y. We'll figure out how to do that here. To find the x-intercept, you replace the y value with a 0 and solve it. To find the y-intercept, you replace the x value with a 0 and solve it. So let's do that with this example. Find x and y-intercepts of y equals x cubed minus 4x. So if I do x-intercepts first, okay, to do that, it says to replace the y with a 0. 0 equals x cubed minus 4x. Well, how do you solve this for x? First of all, I can't combine like terms, I know that, but what I can do is factor out an x out of both terms, and I get x squared minus 4. You should recall that x squared minus 4 is a difference of squares that can be factored as x minus 2 times x plus 2. And that x just carries down. Still all equal to 0. Now, you notice I have 3 x's. That's because it was x cubed. So we'll have 3 x-intercepts. Take each x value or take each part and equal it to 0. X equals 0. X minus 2 equals 0. X plus 2 equals 0. And we can solve it. The first one is x equals 0. The second one equals 2. This one, subtract 2, and I get x equals negative 2. So there's my 3 solutions. My x-intercepts are 0, 0, 2, 0, and negative 2, 0. Those are my x-intercepts. Halfway there. Y-intercept. Okay, come back to the rule. The rule says to replace the x with a 0 and solve it. So y equals 0 cubed minus 4 times 0. 0 cubed is 0, minus 4 times 0, which is 0. So y is just 0. So my y-intercept is 0, 0. I only have one y-intercept, and I have 3 x-intercepts. That is possible, happens all the time. Okay, graphs of functions continued. Let's talk about symmetry. Symmetry is with respect to a certain axis. Okay, so that's what the WRT means, and that's in the abbreviation. Now visually, if it's symmetrical to the x-axis, it could look something like this, or what I call too as a hamburger fold. Okay, if you can hamburger fold it and the images match, then it is symmetrical to the x-axis. If it's symmetrical to the y-axis, it's the hot dog fold. Okay. Lastly, if it's symmetrical to the origin, that is your cubic function. And in order to do that, you would have to do the hamburger and the hot dog fold. Okay, so that gives you the visual. How do you do it graphically? Well, that's the easy part. Algebraically is what I want to focus on, but I want you to know what I'm talking about here. Now, algebraically, if it's symmetrical with respect to the x-axis, you can replace the y with a negative y value and the equation is unchanged. If it is symmetrical to the y-axis, you can replace the x with a negative x and the equation is unchanged. If it's symmetrical with respect to the origin, then you can replace the y with a negative y and an x with a negative x and the equation is unchanged. Okay, so let's try this. And that's a lot of words on that last slide. Let's just look at this. Determine the symmetry algebraically without graphing calculators using this equation right here. Okay? So use the symmetry to sketch the graph. That's your last step. So with respect to x-axis, that means I take the y, replace it with a negative y, and see if I get the same equation. So x minus negative y squared equals 1. I can simplify this. Negative times a negative, when I square it, becomes positive. So it's x minus y squared equals 1. Is that the same as the original? Yes. So it is symmetrical to the x-axis. With respect to the y, I take the x and I replace it with a negative x. Is it going to be the same? Negative x minus y squared equals 1. I can't simplify this any further. Is this the same as the original? No. So it is not symmetrical with respect to the y. With respect to origin, I have to do two steps. Y changes to negative y and x changes to negative x. You have to do both. Okay, so negative x minus negative y squared equals 1. Is this the same? I can simplify here. Negative x minus, remember a negative times a negative becomes positive. Is that the same as the original? No, the x is negative here. It's positive in the original. So this is a big fat no. Now I need to graph this guy. Okay, in order to graph this, I need some xy coordinates, but I need to set my equation equal to y first. So I need to do a little algebra. So I'm just going to solve this for y. Hopefully you can do this pretty simply. I need to make that a negative or a positive y squared. So I'm going to multiply both sides by negative 1. So I have y squared equals positive x minus 1. I need to take the square root of both sides. So y equals the square root of x minus 1. This is what I'm going to plug into my xy table, giving me points. Choose something simple. Let's start with a 1. If I make x 1. If x is 1, 1 minus 1 is 0. The square root of 0 is 0. If I do 2, 2 minus 1 is 1. Square root of 1 is 1. 3 is going to give me an imperfect square. 4, 5. If I put a 5, I'm looking for perfect squares. 5 minus 1 is 4, which is a perfect square. The square root is a 2. This gives me 3 points I can plot and see what's going on. So at 1, y is 0. At 2, y is 1. At 5, y is 2. So if I connect these dots, I begin to see this curve. Now I know from all this previous work that it is symmetrical to the x-axis. So what it's doing here, if I hamburger fold it, it is doing this way as well. So that's how you use that information to help you graph. This last example I want you to do in your notes. Make sure you show your work, and you're going to graph it using the symmetry that you find. In the whisk, I'm going to ask you, what is the symmetry? You can tell me the symmetry is the x-axis, the y-axis, the origin, or it may have no symmetry. So just keep that in mind. But show your work and your graph. Those things I will be looking for in your notes when I check them. Thank you.